feel low, you can still go. Even when you feel slow, you can still go. Even when there's no hope, you can still go. I never answer to no, man, I still go. Go, 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 yo, go, go, go.
Alright, so I'll be honest, part of me hates these Fusion 360 rendered promo videos. But for this product at this time, it's all I have to show, so bear with me. I'll be able to provide videos of these motors being flown into concrete walls soon, I promise, but that will take time. Earlier this year, I was working on manufacturing an eVTOL DIY kit. eVTOL just stands for Electric Vertical Takeoff and Land. I want to provide a DIY kit to Australia of one of these machines, because they're fucking inspiring. Anyway, so I'm still working on this, but when I naively tried to source the Australian components to be able to build the motors for that, I realised just how little we actually manufacture here in Australia. This means that if I want Australian-made motors, I'm gonna have to organise it myself. To make life easy, I decided to zone in on a specific small motor, the 2306. It'll be a uni-bell design, and between 1700 kV and 2400 kV. Hasn't been specifically decided yet where I will fall in terms of kV, but it will be around that range. The parts and the manufacturing process can be divided up between 8 sections. I'll cover each section and describe exactly where I'm at with the research and development of the Australian-made motors. There's the 314 stainless steel bolt, the base, bell, magnet supporting band, not really sure what to call that one, bearings, hollow titanium shaft, stator, and magnets. The base and the bell. Okay, so these two parts are going to be made from 6061 aluminium. This is just because it's more friendly to fabrication than 7075. We might move to 7075 down the line after the prototyping is done, but we will see. Okay, so these two parts, they're going to be machined using a CNC router/milling machine at the beginning, and after we're out of the prototyping stage, we'll move to injection molding as the solution for mass manufacturing, I guess you might say. It's just that the injection molding process is a lot more expensive when you're in the prototyping stage, so it's not quite justifiable. Not while we might have to be making corrections. The bolt holes or mounting pattern on the base will be 16mm by 16mm, so that it can fit most quad frames that are out there. I'd love any feedback from people if there are more universal mounting patterns than that, but I'm just not too sure yet. The ridges on the top of the bell, they are facing outward instead of inward, and this is for better prop grip. I haven't tested this myself, but this was one of the notes that a lot of people gave me as something to pay attention to with this design. So, a little detail that might make the difference. The pattern on top of the bell is meant to be reminiscent of Norse runes. This is really just for aesthetic appeal, but I went for a combination of the Helm of All and the Algiz. Yeah, you guys can look them up if you want to, but that's just my personal sort of heathen touch on this design. At the same time though, this orientation should, by rights, add extra cooling for the motors. This is because of the way the claws are shaped to catch air and drag them down through the motor. Though of course this hasn't been tested yet, so that is an empty claim until I have anything to back that up. The magnet supporting band will be made via additive manufacturing, which is just a fancy way of saying 3D printing. We're going to be testing the material because we haven't decided exactly what is suited yet, but this component is essentially to lessen the possibility of your magnets coming loose after a strong hit. So it might be one of those little things that improve the quality of the motor just that much more. The copper wire is already manufactured in Australia and will be rated between 200 and 260 degrees. Though it's not sure if this additional 60 degrees of leeway is just a marketing gimmick or not, so more research is going to be needed into that. The gauge of wire we're going to be using is going to be 1mm, just as a good benchmark for us to move up or down from if desired, if we need to match kV. And the wire will be machine wound around the arms of the stator to ensure that every wind is identical and as tight as possible. The winding pattern will be DLRK evolution. Apparently, this is desirable as it makes the terminations of the windings easier and neater, and apparently this is a little bit better on a factory winding process. But we'll have to see. I'm also open to recommendations when it comes to anything I'm talking about here. The two bearings used for this motor will be 4mm by 9mm by 4mm. This larger sized bearing should by rights increase the life expectancy of the drone motors. The material used for these bearings will be a mixture of stainless steel and chrome alloy, just for the best of both worlds. And these bearings will be custom manufactured in Australia through existing companies. Though it is likely that this will be moved into in-house production down the line if all is successful. It's not decided yet if these bearings are going to be sealed or not, and that's just because the benefits kind of seem to equal the negatives. So we just need to research a little bit more and get more of a concise answer. If anyone has any opinions on the best type of bearings to go with, or if you prefer sealed or unsealed, then let us know. The titanium shaft will be 5mm thick and was requested specifically. Of course, we're happy to oblige because this will mean extra durability, and we've also made it so that this titanium shaft will be semi-hollow, which means that we can balance strength and weight. Now, this particular component is not going to be manufactured in-house. Instead, it's going to be sourced from companies in Brisbane. This is because of the complex tolerances associated with the titanium shaft, specifically the teeth that allow for press fitting together of the bell to the base. This is something that we want to do perfectly, so we will getting specialist help. The stator is the second most complicated part of this endeavor. It is made of non-grain orientated silicon steel, also referred to as electrical steel. The steel plates that we're going to be using to begin with will be 0.5mm thick, but we also want to test 0.1mm thick. These are stacked together via a process called self-piercing riveting. This is a process that interlocks the stator plates with a punch rather than having to weld the thin plates together. This allows for a more friendly mass production process, and less complicated equipment is required compared to the welding method. Each layer of silicon steel is separated by thousandths of an inch of lamination. This acts to insulate each layer apart from one another. After the stator plates are punched, laminated, and stacked, a special type of thin epoxy coating is applied, then baked and set. This epoxy serves to help with heat dissipation. It's worth pointing out that the stator side of this project is really the most exciting part to me, just because we have the raw resources mined in Australia. We just don't have the infrastructure yet to be able to process it into the stators for motors. Now, I have heard that there are a couple of motor companies making stators in Australia, but they are not open to working with other businesses. So if I do solve this and get Australian-made stators from Australian mined material, I will be opening that up to the public. This part of the project is by far the most difficult section. You wouldn't think so at first sight, because neodymium magnets are just made up of neodymium, iron, and boron, all of which is mined in Australia. To put it simply, The manufacturing process consists of mixing the resources, consisting of neodymium, iron, and boron, and then casting them into ingots. These ingots are then pulverized into a powder, which is in turn sintered and magnetized, then baked to form the permanent magnet. This sounds straightforward enough until it comes down to the separation of the neodymium and dysprosium at the raw resource level. Dysprosium has radioactive properties that are removed via selective precipitation. Now, I looked up an easy definition of this process for those listening, and selective precipitation is a technique of separating ions in an aqueous solution by using a reagent that precipitates one or more of the ions. This leaves the remaining ions in the solution. The aqueous solutions used are benzene, diethyl ether, or HCl complexes with tripoidal nextride ligand. Okay, now this part is really important because the dysprosium is radioactive, so that has to be removed before the raw resource can be processed. So this also provides a lot of promise, especially in terms of investment opportunity. Because as I was saying before, we do mine all of the raw resources, and we didn't mine these resources 30 years ago. As you can imagine, with every passing day the scope of this project extends farther and farther, but it is by solving real problems that Vikingr Industries will prove itself. Initially, this will benefit the freestyle racing drone industry, but once this is accomplished, the infrastructure created will be made open to the rest of the world. Australia can become a manufacturing hub again. It will just require an incredible amount of work and the support of the Australian people. The final point I want you all to consider when pondering the end-to-end manufacturing of electronics in Australia is the case that can be made for it being vital to our civil and national safety and defence. I know it is an extreme hypothetical, but in the event of a wartime scenario, we have to be able to manufacture the vital resources we need to keep Australia going. And there we have it. That is my attempt to describe the end-to-end manufacturing of Australian-made motors. We mine the raw resources, we have the intellectual capability, we just need the infrastructure. If you want to help, send us a message or like the page. If you're feeling generous, share the post. I really do need all of the support I can get, and my ego does not extend far enough to take this responsibility on just by myself. I really am looking for partners, and I'm looking for other companies to work with. Even if you're not sure what you can bring to the table, but you're interested, send me a message. I'm also looking for investors and advice, or advice in getting investment. So I hope you guys liked the video. I'm not accustomed to making or editing this sort of thing, so God, it is time consuming. But I like knowing that the information is out there because a lot of this information has taken a long time for me to collect.